Alright, so this video is going to show us how to set up the calorimetry apparatus, the calorimeter here. It's just a styrofoam cup calorimeter, right? So our styrofoam cup calorimeter, we just have the stir plate. Again, we're not heating anything here. We have a couple of styrofoam cups held with a ring stand, and then inside we have our stir bar stirring. Alright, this lid doesn't fit tightly, but it does the job. Okay? And in there is where we would put our water and eventually add our salt. Okay? Our microlab interfaces here. We have our USB cable that we need to plug into the computer. We have our power source that needs to be plugged in as well. Okay? So we plug in our power source. Make sure the power source is plugged in correctly on the back of the microlab interface. Make sure the USB cable is plugged in there on the back. And the USB cable needs to be plugged in up here, right? Okay, so now we're all plugged in. We're going to want to make sure we turn on our power button here. There we go, and we can look down and see there's a green light on in the little O in the microlab, so the power is flowing there, okay? And to hook up our calorimeter setup, or to set up the calorimeter to hook up a heat sensor, a temperature sensor, we're going to go into Start menu. We go to All Programs, right? And under the microlab program there. And so it's plugging in like that. All right, so we saw that power, kind of that power bar powering up, loading up. I'm going to close this now and show you what happens when you try to just cancel here, I guess, and then we'll close this and we'll try to reopen it, but this time I'm going to unplug this. So if this is unplugged, if your power source is unplugged, or if this isn't on, if there's no way for the computer to connect, then when I go down here to open up my microlab or the program here, it'll give you this window here. And this window you can say simulate program, and then it will open up the program like this, right? So this is just a simulation, and you can manage files and manipulate data and stuff in here, so there's use for this, but you won't be able to interact with the interface, okay? So this is not where you want to end up. All right, so we're going to close this. This time we're going to reopen it, but this time we're going to make sure we have it plugged in. So don't trick yourself in thinking you have everything set up correctly, but actually not have everything plugged in, all right? So again, we're going to open it up again now with it plugged in. We have our microlab, the software there. And then again, we see this loading window which shows us that we're connecting to the interface. Okay? For the temperature probe, we're going to open this window here. This is the microlab experiment. This is what we're going to open for actually all of our labs. So we just double click here, or we can just push OK. And then that opens up this window here. This is where we're going to add our devices, our sensors. Over here is where we plot out our results, and over here is we can view what our sensors are reading. Here is a spreadsheet which records our results, and we want to make sure we record our results in the spreadsheet. We want to make sure that our results are plotting out here and that we can actually see the results, to always double check that our sensor is giving out a reasonable number. Okay? Now, for this calorimeter lab, for this heats of solution lab, we need to have a temperature sensor. So the temperature sensors are over in this drawer here, right? Again, our interfaces came from this drawer, right? Our interfaces are all in here, the power supplies and the USB cables in these first three drawers. Our temperature sensors, right? They come in this drawer here. There are three types of temperature sensors. We have this one here, which is called a thermistor, okay? We have a thermistor. We have one in the back of the drawer here, which is called a thermocouple. All right, there's a thermocouple there. And then we have a temperature probe on the silver bag. Sorry, the silver bag one. And I'll get this one out here. This temperature bag one is called an IC probe, integrated circuit probe. Okay, so we have three different sensors. Probe, we have the thermistor here, and we have the thermocouple. All right, and you're going to want to use the thermocouple. Okay, so we're going to take the thermocouple over here. Okay, We take the thermocouple out. The thermocouple is a wire that has two metals, and the junction of those two metals creates a voltage when we connect those two metals together, and that voltage is dependent on the temperature. So as the voltage changes in the wire, then you can identify what the temperature is, right? You can see there's a large prong, a thicker prong, and a shorter prong, or a thinner prong, and the longer prong goes into the left, as shown here by this little device. You click right up here on the software. Okay, so we have our thermocouple plugged in. We have it in a cup of water, a calorimeter here, double cup of water, stirring, and we're going to calibrate it now. Or first we have to add the sensor. So we go to this part of the screen here and we click Add Sensor, and then it brings up this window, and here we choose the sensor, which is the temperature thermocouple, the thermocouple. All right, and then this part right here lights up. Click that because that's where we have it plugged into, right? Click there. We go next to calibrate this. We're going to perform a new calibration. So we perform a new calibration. We have to add a calibration point. The calibration point that we have in now is room temperature water. We can put our thermometer in there and check out the temperature of the water, right? We can monitor the temperature of the water. Type that value in here. And then we push OK. These thermocouples are very sensitive, so we can click up here because that red line should be within the green before we push OK. So we can lower the sensitivity so that the red line will settle. Then we click OK. Now we've added 1 point on our calibration curve, and we want to have 3 points. We add another point on our calibration curve. This one we're going to do some ice water, right? Nice cold ice water. So we take our thermocouple, place it into the ice water. All right, put this into there. Wait for the temperature to stabilize on the thermometer. Okay, then we come back up here and we see that the thermometer says 0 degrees, so we change this, and you have to type in a 0. If we want to, we could do this to verify that the sensitivity or that it's stabilizing well enough. We could also look at this curve and see that it's stabilizing also. Then we say OK. Now we have 2 points, a 0 and a 20 degrees. Now we want to get a warm one. To get a warm one, we have some hot water heating over here. Right, I use the glove. I take the bottle carefully over to my spot without spilling it on me or anybody else. I put my thermometer in. I put my thermocouple in. All right, thermometer's in, thermocouple's in. Wait for the thermometer. Take my glove off so I can use the mouse. Wait for the thermometer to stabilize while I'm adding another calibration point. I can click up here again and go down here, make sure that the thermometer is stabilized, that the thermocouple is stabilizing. Look at the temperature on there. And the temperature says 56 degrees. So we type in here 56 degrees, whatever the temperature says, and then I'm going to say OK. All right, now I can see that there's 3 points, and I'm going to fit them with a linear, first order linear fit. And then I say accept and save this calibration. I want it to report to me as units of Celsius, so I type that in there, press OK. Then I say I want to save this file just in case the computer has a problem or anything. I can save it on the desktop as something that is familiar to me, so that I can come back and read that calibration file if I ever have to recalibrate this. Say finish, and now we're done. We can take that thermocouple, put it here. We could drag the thermocouple, I'll do that again. We take this thermocouple here, we drag it down onto our y-axis. We take it from our y-axis, we can also drag it over to here, and it should be telling us the temperature, and it is telling us the temperature of that hot water right now, right? And that's good. Now that that's there, we can always monitor and verify that whatever the temperature is, it's reasonable, right? So if for some reason this value goes to some unreasonable temperature like 1,000 or 0.000005 or something like that, then we know that it's not working. But here we have it back in room temperature and it's about 18 degrees Celsius. All right, so we've calibrated our thermocouple that way. All right, so now I have a thermocouple, a temperature sensor. I'm going to add one more sensor because we want to have a plot up here of temperature versus time. So I'm going to add a timer. To add a timer, you just go to time, click on one of these boxes, next. You can choose if you want to change it to seconds, but then finish, and that should be it. So now I have a timer and a temperature sensor. The timer I drag down to my x-axis. The temperature sensor I drag to my y-axis. Alright, so now I can set this thermocouple up either by opening up this lid or just sneak it in like that. Whoops. Gotta finagle this thing so it wants to go down. Alright, so now my thermocouple's in there. I have a stir bar in there stirring away. I can fill it up with my 100 milliliters of water and then add my salt, and then I can monitor the temperature change. To get this thing started, when I'm ready to start, before I add my salt, I'm going to say start, click on the start button, and that's going to start monitoring the temperature versus time. Every second it's going to take a temperature point. You see down here it's plotting the temperature versus the time. And as I would add my salt, maybe if I put first, that represents my 100 milliliters of water, and then I maybe add a little bit of potassium chloride, and as I add potassium chloride, I'm going to create a exothermic reaction, right? So this is just water, but I'm pretending like it's potassium chloride, which is going to give me an exothermic reaction, sorry, endothermic reaction, where the temperature goes down, right? So I've cooled down. Now I have enough data there. I can push stop. I can see that my high temperature was about 19.9, about 20.2 there. My low temperature was about 17 degrees, right? So I can see my temperature change, get my temperature change from that data. I don't know exactly, let's see, if I rest right here and click right there, does it tell me that data? Right click, graph proper, oh there we go, right click. It tells me it's 23.38. So there's my temperature right there. If I click right here, 24.90. Oh no, sorry, 17.2. 17.2 is it. There, and did I get the right value there when I went here? The temperature was 20.1. 20.11. So 20.11 down to 17.24. So there's my delta T. I can get that value. Now, I'm going to want to manipulate this in Excel maybe, or print it up in Excel. I can just print this graph if I want to, but then it's kind of large and cumbersome to work with. If I go to File, Export Data As, comma separated value sheet, I want to put this on somewhere like the desktop, and I can call it maybe Experiment 1. And I could probably put in there KCl or whatever the salt was that I used, right? And then I say save. Now on the desktop, that's there on the desktop, so I can open Excel. I can open that file on the desktop. If I open it like that, I see there's no file there because we're just looking for Excel files. But if I go to all files, then it opens all the files, and I can find my Experiment 1 KCl that I saved. Double click on it there. Now I have my data here, and I can insert a graph that I'll be able to save. Whoops, I have my X and my Y axis reversed, so I can drag my X, I can click right here, switch my axis this way. There we go. Now my axes are right, and I can change the scales here and have this graph look just like I want it to. And I can label it and everything. All right, we're going to want to do about 3 samples of KCl, 3 samples of every salt to get a good average, right? Average delta T. All right, so that's how this setup is going to work.
All right, one more question.